Good morning, students. Today we will continue our chapter 9 Force and Laws of Motion further with the topic Laws of Motion. There are three laws of motion. First law of motion, second law of motion, third law of motion. All these laws of motion were given by scientist Isaac Newton. That is why they are also known as Newton's laws of motion. Now, first of all, we will discuss first law of motion. Now, what does this first law of motion state? First law of motion states that an object remains in the state of rest or of uniform motion unless an external unbalanced force is acted upon it. So, this is first law of motion. First law of motion states that an object remains in the state of rest or of uniform motion unless an external unbalanced force is acted upon it. It means if an object is at rest, it will remain at rest. If an object is in uniform motion, it will remain in uniform motion unless or until an external unbalanced force is acted upon it. So, we have to apply an external unbalanced force on the object to change its state from rest to motion or motion to rest. Otherwise, its state will not be changed in the absence of external unbalanced force. Now, the question is, what makes an object to remain in the same state in the absence of external unbalanced force? The reason behind this is inertia. Inertia is the property or tendency of every object to remain in the same state of rest or of uniform motion until or unless an external unbalanced force is acted upon it. This is the property or tendency of object by which an object remains in the same state of rest or of uniform motion until or unless an external unbalanced force is acted upon it. Due to this property only, the object opposes or resists the change brought by the force initially. So, if we are not applying any external unbalanced force on the object, its state will not be changed. It will remain in its original same state of rest or of uniform motion. That is first law of motion, and this is due to the property or tendency possessed by that object known as inertia. And if we are applying any external unbalanced force on the object, so we are applying external unbalanced force on the object, so it's obvious that its state will be changed either from rest to motion or motion to rest. But initially, due to the property or tendency called inertia, the object opposes or resists the change in state brought by the external unbalanced force. Means that object opposes the change in state and tends to remain in the same original state of rest or of uniform motion. But ultimately, it has to come into new state because an external unbalanced force is applied on it. Although it opposes or resists the change in state initially. Ultimately, finally, it has to come into new state, but initially it opposes or resists that change in state brought by the external unbalanced force. This is because of inertia. So, I can conclude that inertia is the property or tendency of object due to which it remains in the same state of rest or of uniform motion until or unless an external force, unbalanced force, is acted upon it. And because of this property only, that object resists or opposes the change in state initially brought by the external unbalanced force. So, first law of motion is due to inertia. That is why this first law of motion is also known as law of inertia. Now, I am going to tell you few of the examples based on inertia. You must have seen that or experienced that when we are in a moving car and suddenly driver applies brakes on the car comes to stop and we get a forward jerk, we fall forward in that car. Why does this happen? This is because of inertia. How's that? See, when we are in a moving car is in motion and we are in that moving car, so we are also in motion. Suddenly driver applies brakes on the car. In this way, driver applies an external unbalanced force on the car. Due to that force, car's state is changed from motion to rest. In this way, car comes to rest. That force is also acted upon us because we are also in the car. So if any force is acted on the car, so that same force is also acted on us. So due to that external unbalanced force, our state will also be changed from motion to rest. But because of inertia of our body resists, opposes this change in state and tends to remain in the same state of motion, and opposes the change in state means opposes the state of rest. So our body, due to inertia, does not want to come in rest. It tends to remain in the same state of motion. So what happens? As the car stops, our body, due to inertia, does not stop. It tends to remain in motion and car stops. That is why we fall forward. So this is an example based on inertia. Next example, when we are standing in a parked bus, means a bus which is stationary or at rest. What happens? Driver accelerates bus from rest and due to that bus starts from rest to motion. Now what happened with us? We get a backward jerk or we fall backward. Why does this happen? Because of inertia only. See, our feet is in contact with the bus floor. So what happened? First of all, bus and our feet, which is contact with the bus, both are at rest, both are stationary. But when driver accelerates bus from rest, then what happened? He applies external unbalanced force on the bus, which changes the state of the bus from rest to motion. That force is also experienced by our body. So we have to come in motion from rest. But due to inertia of our body opposes or resists this change in state brought by the external unbalanced force, and our body tends to remain in the same state of rest and does not want to come in the new state that is of motion. So what happens? Bus starts, bus accelerates, bus moves, but our body, especially our feet, which is in contact with the bus floor, due to inertia, our body tends to remain in rest. So bus starts, bus moves, but our body, especially our feet, which is in contact with the bus floor, due to inertia tends to remain in the same state of rest and does not want to come in motion. So bus comes in motion, but our body tends to remain in rest. So what happens? As the bus starts, moves, our body, which tends to remain in the rest due to inertia, get a backward jerk or falls backward. This is because of inertia. Now third example. When our moving car takes a turn on hilly mountainous region, then what happens? We fall sideward. Why does this happen? The answer is same, because of inertia. What happens? When the car is in motion, we are also in the car, so we are also in motion, but in a particular direction. So along with the car, we are in motion in a particular direction. Now, as the car takes turn, then an external unbalanced force is acted on the car which changes the direction of the car. Same force is acted upon us because we are also in the same car. So it also changes our direction, but due to inertia of our body opposes or resists this change in direction and tends to remain in same direction. So what happened? Due to the application of external unbalanced force, the direction of the car changes and our direction also changes, but after some time, because initially due to inertia our body opposes or resists this change in direction and tends to remain in same direction. So what happens? As the direction of the car changes, we tend to remain in the same direction. So what happens? We fall sideward. So this is because of inertia. Now, fourth example. Take a glass tumbler and fill it with water. Take a glass tumbler, fill it with water and then place a cardboard over this glass tumbler and then keep a 5 rupee coin on that cardboard. Now, give a flick to this cardboard. What will happen? This cardboard will fly away and this coin will fall in this glass tumbler. Why does this happen? This is because of inertia. See, coin and cardboard both are in contact with each other and cardboard is at rest, so coin is also at rest. So both are in contact with each other and both are at rest. Now, as we give a flick to this cardboard, an external unbalanced force is acted on the cardboard which changes the state of the cardboard from rest to motion, so cardboard flies away. Same force is acted on the coin. So due to the application of an external unbalanced force, its state will also be changed, but due to inertia it opposes, it resists this change in state and tends to remain in the same original state, that is of rest, and does not want to come in new state, that is of motion. So what happens? When cardboard flies away, this coin does not fly or move along with this cardboard. So cardboard flies away, but this coin does not fly away or move with this cardboard. It tends to remain in the same original state, that is of rest, and does not want to come in motion. So it remains here for a while, and what happens? cardboard has already moved, flied, and this coin remains here and falls in a glass tumbler. This is because of inertia. If let us assume inertia is not there, then this coin would fly away or move with this cardboard. But every object possesses inertia, and due to inertia, it tends to remain in the same original state, that is of rest, and does not want to come in a new state, that is of motion. So it does not go or move or fly away with cardboard. It remains here due to inertia and then finally fall into glass tumbler. Now next example. When we shake a dusty carpet, what happens? Dust comes out of it. Why does this happen? This is because of inertia. Now there is a dusty carpet which is containing dust. Now when we beat that dusty carpet with a stick, dust comes out of it because of inertia. See, that carpet and dust in it are at rest. Now when we beat it with the help of stick, then we apply an external unbalanced force on the carpet as well as on dust. Due to the application of external unbalanced force, the state of the carpet as well as dust is changed from rest to motion. Here, carpet comes into motion, it starts moving due to the application of external unbalanced force. Now that dust, initially dust due to inertia opposes or resists this change in state or tends to remain in the same state of rest and does not want to come in motion. So as carpet starts moving, along with that dust does not move. It tends to remain in the same state of rest and does not want to come in motion. So what happens as the carpet starts moving due to external unbalanced force? Dust remains there. So what happens? Carpet starts moving and dust remains there. So what happens? Automatically dust has moved out from the carpet because carpet's state is changed, it starts moving like that, and dust remains there, so automatically it has came out, moved out. So due to inertia, carpet is freed from the dust. Now next example, you must have seen that when we shake the branch of a tree, most of its leaves get detached because of inertia. Because when we shake the branch of the tree, what happens? That branch and leaves attached on it are at rest. Now as we shake the branch, an external unbalanced force is acted on the branch as well as leaves. Now what happened? Due to the application of external unbalanced force, that branch comes into motion from rest. Same force is acted on the attached leaves, so that leaves will also come into motion from rest, but initially due to inertia, leaves oppose or resist this change in state and tend to remain in the same state of rest and do not want to come into motion. So what happens? As we shake the branch of tree, the branch starts moving, starts shaking, starts vibrating, it comes into motion, but the attached leaves due to inertia do not want to come into motion. They tend to remain in the rest. They tend to remain there only at the fixed place. So what happens? As the branch starts moving, vibrating, That attached leaves due to inertia tend to remain in the same state of rest, tend to remain in the same place, get detached because branch starts moving. So branch position is changed from here there, from here there, and the attached leaves which are attached on it, they tend to remain there. So they get detached because of inertia. So these are various examples based on inertia. You are always advised to tie your luggage on the roof of the car or bus with a rope. Why are you advised like that? This is because of inertia. Because as I told you earlier, as a moving car or bus comes to stop, then due to inertia, you fall forward. In the same way, luggage can also fall forward. And as the parked car or parked bus accelerates from rest to motion, again, if you are standing or sitting in that car or bus, fall backward, in the same way luggage can fall backward. So to prevent your luggage from being fallen down, you have to tie your luggage with a rope on the roof of the car or bus, so that due to inertia it will not fall forward or backward. The ropes will keep that luggage at that particular place and prevent it from being fallen down or from being damaged. Now, you are also advised to use seat belt while driving or while sitting in a car or any automobile. Why? Because what happened, as the moving car comes to stop, then what happened, due to inertia you fall forward and your head or any other body part, especially head, can strike with the front part of the car, and it can cause injuries to you, severe injuries. So to protect yourself from being injured, you have to you must use seat belt. And what will happen, due to inertia, it's obvious that your body will fall forward as the moving car stops. Then seat belt that you are wearing, that seat belt will push you backward. So due to inertia you fall forward, but seat belt will push you backward. So ultimately, as a result, you will remain at your place, at your seat, you will not be injured. So these are various examples in relation with inertia. Now there is a question, do all objects have same equal inertia? No. Different bodies, different objects have different inertia. Inertia depends on mass. Mass is the measure of inertia. You can measure any object's inertia with the help of its mass. If object is heavy, massive, if its mass is more, then it will possess more inertia. And if it is light, its mass is less, then it will possess less inertia. So inertia is the quantity which depends on mass. So mass is the measure of inertia. Mass is the parameter or criteria on which you can measure inertia. Okay, for example, there is a stone, along with that there is a football. That stone and football both are having same size, but we all know that stone and football having same size, but they differ in their masses. Stone obviously has more mass and football has less mass. Now if I will ask you to kick both stone as well as football, then in which case you will have ease to kick. Obviously in football, as you kick football, then what will happen? You will kick football easily, readily, smoothly, and that football will move away. Now, in case of stone, if you will kick stone, then what will happen? You have to kick that stone hardly. You have to apply much more external unbalanced force on the football so that it can move away. And while kicking, you can have injury also. So why does this happen? Because that stone and football have different masses. Stone being more massive, being more heavy, due to that it has more inertia. And on the other hand, that football, it is light in weight, it has less mass, so it has less inertia. Then how it will make a difference? Yes, it will make a difference. Now that football is having less mass, football is light. So what will happen? It will possess less inertia. So when we kick football, so we have to kick it very smoothly with less effort. We have to kick it. So in short, I can say we have to apply a less external unbalanced force on the football to change its state from rest to motion. Why? Because its mass is less, so its inertia is less. So it has less tendency to oppose the change in state brought by the external unbalanced force, and its state will be readily easily changed from rest to motion even in the case of less external unbalanced force. So we have to kick it very lightly, with very less effort we have to kick it. So we have to apply less external unbalanced force. Then what will happen? Due to less inertia, it will oppose or resist the change in state brought by the external unbalanced force, but up to less extent. It will not oppose or resist that external unbalanced force applied by you so much. It will oppose or resist that force or the change in state brought by the force up to a less extent, and easily its state will be changed from rest to motion. Now in case of stone, its mass is more, its inertia is more, so it has more tendency to oppose the external unbalanced force applied by you. Then what happens? As you kick it, then you apply external unbalanced force on the stone, then stone being more massive possesses more inertia and opposes or resists the change in state brought by the external unbalanced force more. So its state will not be changed. So you have to apply more external unbalanced force, a large external unbalanced force. You have to kick that stone hardly, with great effort you have to kick it, so that you can apply much more external unbalanced force, so that that stone cannot oppose or resist that change in state brought by the large external unbalanced force up to great extent, and then its state will be changed. So you have seen that if object has more mass, then it has more inertia, and if object has less mass, then it has less inertia, and if more mass, more inertia, so it has more tendency to oppose or resist the change in state brought by the external unbalanced force. So in that case you have to apply much more external unbalanced force to change the state of that object. On the other hand, if object has less mass, less inertia, so it has less tendency to oppose the change in state brought by the external unbalanced force. So its state is readily, easily changed. So you need not to apply much more external unbalanced force. If you have to pull an engine of a train and on the other hand you have to pull a bicycle, in which of the cases you will pull a particular object with great ease? Obviously in the case of bicycle, because bicycle has less mass, less inertia, less tendency to oppose the change in state brought by the external unbalanced force. It has less tendency to oppose the external unbalanced force applied by you. So as you pull the bicycle, being light, being less massive, it possesses less inertia, it has less tendency to oppose or resist the change in state brought by the external unbalanced force. It has less tendency to oppose the external unbalanced force applied by you. So what happened? Its state is easily changed from rest to motion. And this is not in the case of an engine of a train. Now, next example. Here you place a 5 rupee coin. In case of 5 rupee coin, place a 1 rupee coin. Now, think over the situation. In which of the cases you will have ease to kick the cardboard? Obviously, in case of 1 rupee coin. Because 1 rupee coin has less mass, less inertia and has less tendency to oppose or resist the change in state brought by the external unbalanced force, and it easily comes into new state by the application of your force. So this is all for today. Today we have completed first law of motion. In our next class we will discuss second law of motion. Thank you. Have a nice day.